All right, we'll get started. So my name is John Pozivilko. I manage the Cloud Platform Services team, and welcome to this afternoon's session on AWS Outpost. So I'm going to do a technical overview of it. The presentation will start at kind of a high level and talk about the Outpost services that are available. As we progress through the slides, we get a little more technically detail around actually the physical hardware that's used, and so we'll talk about hardware quite a bit. Also, we'll talk about the network configuration within AWS and how it talks to your on-premise environment. And then there'll be a couple of slides about how you connect this hardware in your actual facility to the switches and routers that exist in the data center. And then I'm going to do a little bit of a presentation on AWS Nitro, which is hardware they use to create Outposts. It's actually used in the cloud too, but it's kind of, once they came out with the AWS Nitro program and finished it, it's what made Outposts possible to do. And then finally, I'll do a little bit of presentation on the pricing for Outposts. So this is Outpost. It's basically a rack with servers in it and switches and power supplies and stuff like that. And the idea is that this is Amazon's hardware. They ship it to your facility, you put it in your data center, hook it up to your network, and voila, you have an AWS presence on site. The hardware itself is the exact same hardware that runs in AWS facilities throughout the world, so there's no difference in terms of what would be sent on site. It's managed by AWS. They're monitoring it, and API calls, so for instance, CloudTrail, CloudWatch, all those activities that you can do today in the cloud, you can do in your on-premise installation too. So as I mentioned, it's fully integrated, fully managed by AWS, same exact hardware, runs on the Nitro systems. We'll talk about those a little later. Talk about the API stuff. Bottom line there is automatically monitored, updated, and patched. Interesting thing there is, we really don't see it in the cloud today, but Amazon is doing firmware upgrades to servers, putting new code base on it for new functionality and features and stuff like this. So they would treat this on-premise hardware the same as the stuff they do in their facilities. So they would be pushing patches and updates to it. Seamless to us. They have redundancy built in so that if you would have hardware failures or if they have to reboot a server, physical hardware server, you wouldn't notice it because they're able to move things around. It's available in 2 flavors. As of today, you can order it with native AWS. Go on site, order it, put your configuration in, ships, and you can run the Amazon presence in your data center. The one coming in the future is VMware Cloud on AWS. It hasn't, I don't exactly know the exact release date, but the concept there is VMware a number of years ago teamed up with AWS and started to provide VMware's hypervisor on AWS hardware in the cloud. So now you can bring that same experience to your data center. We have a VMware presence on campus. We buy the hardware, we configure the hardware, we set up all the switching, we set up the storage that goes with it. We lay down the VMware ESI hypervisor on top of it. We patch that, we manage it, and we keep it going. In this scenario, that's a paid for service. Basically, hardware is managed by AWS, and then all the VMware infrastructure is managed by AWS and VMware. So then the experience to the end user is just like the cloud for AWS. You deploy virtual machines, create snapshots and manage it that way. You don't have to manage the hardware or any of the software associated with it. So the whole premise around Outpost is the idea of bringing the AWS presence on your local network because of latency issues. If you got processes that run that require a lot of data to be transmitted in a pretty efficient fashion, it's hard to do today going through either public or direct connect type connectivity into the different regions throughout Amazon. The other thing is, and you see some of these use cases here, there's a lot of data processing that has to take place. So a lot of data gets sent to it, do a lot of churning of it, and then something's outputted type thing. So these are some examples that were presented in one of the sessions I attended at reInvent. The one I want to talk about real quick is this medical imaging one, because there was a gentleman from a medical imaging service provider who was actually an early adopter and was in the program of Outpost, helping design the product that's available today. And their use case was this: the service provider in the hospital, they provided all the equipment for MRIs, EKG type of stuff, radiology, gathering all those types of high low-foot latency type things with tons of data. They were managing all that hardware. They had their own servers and stuff collecting it. And then they also had services in the AWS cloud that provided, some type of historical information about this stuff. So anyways, what they were doing is deploying these racks of Outpost servers throughout different regions. I think it was in California to different hospitals, managing all this equipment. And the thing that the gentleman talked about that they really liked is the fact that when you put this rack in a facility, and you really can't do anything with it. You can't plug any devices into it. You can't get to it and do anything on the physical hardware sitting there. Everything's done through the AWS cloud, through the management console that everybody's used to using today. So it made it a really secure footprint for them. Plus, obviously, they didn't have to worry about managing hardware and stuff like that. They captured all this data, had real-time stuff happening in the facility, data processing on it, and then pushed it up to other instances in AWS for the other parts of their businesses. So it's a pretty fascinating talk of some pretty large-scale reasons of why you'd want to put this in your data center. So these are the services that are currently available on Outpost for AWS. The obvious one is compute and storage, EC2 instances. Networking is listed here and it says VPC mainly because once you put this into your data center, the VPC that's defined in AWS Cloud is extended into your data center. So from a management standpoint, it appears as another subnet in your VPC, and it, for all intents and purposes, is another availability zone within the region of Amazon that you're dealing with. Database-wise, there's it's not available today as far as I know. Early adopting program is in place, but that will provide RDS on-premise to do MySQL and PostgreSQL. Containers is supported today, so you could run an ECS container environment from Amazon or the EKS stuff from Kubernetes on site. And then the last one here is the data processing, and I'm sorry, I don't know how to get that off my screen, but we don't use it, but it has to do with elastic MapReduce. So I mentioned the instances. They provide this is what they provide today, the 5 series. And they have the M's, the C's, the R's, and then they do some graphic optimized type of solutions in the storage solution too. All the underlying storage in the particular service is SSD type storage, so GP2. And so you can order different combinations of those types of instance hardware types. This is just another slide that I threw in the presentation. You should look at it later. It kind of tells you why would you choose that particular instance type. For the most part, we're using the M's, the C's, and the R's in Amazon today, but the capabilities are there for other different types of instance types. So, take a look at that if you're wondering, I'm spinning up an instance in Amazon, what's the best thing? This is a quick reference, or you can Google it too. A lot of information out there about that kind of stuff. Storage, I mentioned that, it's all SSD type storage. The thing is, you can still do EBS snapshots on premise. So today in Amazon, create snapshots. You can just take your volume unconnected, connect it to other instances and so forth. And you still will have that capability with the on-premise version. The snapshots are actually generated and stored in Amazon's S3 within the region that the actual Outpost is defined in. The other areas, they offer multiple tiers of storage that you can order online, and these are, the numbers that they have today. The lowest configuration is 2.7 terabytes, and you can go all the way up to 55 terabytes and above. Anything above 55 terabytes, you pretty much have to have special configuration. And the thing to note here, the price of this changes as you get more and more storage. Today, 2.7 terabytes would cost 55 cents per gigabyte per month for that storage. If you're in the 55 terabyte range, it goes down to 15 cents per gigabyte per month. And to give you some reference, in the cloud today, we're paying about 10 cents per gigabyte a month for GPU storage. The other point here is coming soon, and I'm not sure when soon is, but sometime this year, they will also offer S3 capabilities on Outpost in your facility. And not a whole lot of information about this. I did attend a couple sessions and had the opportunity to talk to one of the engineers from Outpost. And he had indicated that, you'll still be able to obviously create buckets, bucket policies, the same things you do today with data at S3 and Amazon. But the other interesting part about it is when it's on premise now, the capability will be in place where you can replicate your on-premise S3 buckets into the highly available S3 buckets in the cloud. I suspect there might be a need to have direct connect as part of the solution based on the amount of data you're going to be pushing, but I don't know. We'll see when that becomes available.
John, just to clarify, I was wondering about this. So based on this last point, if you actually need to have it isolated to the Outpost, it's S3 but without the 9, basically. It's much
exactly
lower durability.
I mean, the 9s would come into play by replicating it into Amazon's infrastructure. Least-wise, that's what I know about it. Now, once it's released, we'll know a lot more about it. So stay tuned on that one. So now let's talk about some hardware. This is actually a slide that kind of depicts what's in a server or in a rack. It's outdated already. At the top is not a patch panel. There's actually 2 physical switches for redundancy that sit on the top of the rack. In the middle is where the hosts are. Those are each 1U servers that are in there. The other thing to note is the power is external to the server. So normally you have power supplies in the server. They're outside of it, and then they have kind of the patch panel stuff going on here. I want to kind of give you an example of what's going on here. This is a typical Dell PowerEdge server, 1U server that we actually use for VMware in our on-premise environment today. And you can see here there's 4 CPUs, a boatload of memory, some power fans in front, some drives stuck in the front of it, multiple power supplies in the back for redundancy, individual network cards, and pretty much if you were to buy a server today from HP, Dell, or anybody else, that's the commodity x83 type server you're going to get. This is from 2016 from a presentation I went to from James Hamilton at reInvent. And he was talking about, and he is the vice president of Amazon's infrastructure services. He's the guy who helps design data centers for Amazon. And in that presentation, he had this slide he showed. And the whole point of them designing their servers and everything they do there is for efficiency. In his presentation, he talked about for their availability zones, which is basically a data center, they design it in such a way that At most, they would say 80,000 servers in that facility. They could do more, but in their idea, if they lost a data center, that's the acceptable number of servers they can lose that would affect customers. And I have a slide later on here that references his presentation. And if you get a chance, take a look at it. It's about an hour, but it's just a fascinating presentation that he gave. The point of this, though, is the fact that that looks nothing like a commodity server. It was engineered for the most efficiency. You know, he was talking about the fact they do greater than 90%, and 1% makes a big difference when you're talking about 80,000 of these in a data center and multiple data centers, regions across the world. So interesting stuff. Today, actually, you know, 4 years later, the power is no longer in it. They have nitro cards now that offload a lot of stuff to CPU and stuff like that. So this is about a 4-minute presentation from a gentleman to basically talk about, he's an engineer on the Outpost team, talking about the hardware and stuff like that. Look at it later if you have a chance. We don't really have time to do it now, so I'm going to skip ahead. So this is just representing the fact that where I said before, the actual Outpost installations are extension of the region. Here's an example of data centers spread out in Los Angeles, Sacramento, and the one on the right is actually in Houston. But from an Amazon AWS console interface, they just look like, you know, availability zones within your region. This is more of the network diagram for this last slide. As you can see here, within the cloud itself, we have subnet 1 and 2 of instances running, and our Outpost, which is running in the data center, is just subnet 3. So, you know, depending on your security groups, you know, you could have instances running on all 3 of these environments, talking to each other pretty easily. The thing to note in this slide is that there is this local gateway, which is new to Amazon. It came out with Outpost, but it basically, the way I understand it, falls in line with like VPCs and transit gateways. Now you have the local gateway for the Outpost device. And the whole point of that is to route all traffic that you want destined to your local facility through that gateway device. And all other stuff goes out to the cloud to Amazon. So this is real quickly just a way you would configure this in your environment to show you how relatively simple it is. The TORs are the top of rack switches. There's 2 of them within the Outpost. Most data centers are going to have redundant routers or switches for their network. So if you lost one, you know, you're still up and running. So the idea is if you lost any one of these 4 things, you're still up and running. But the idea is you do uplinks with LACP into your local data center, and then you configure your local gateway to handle traffic, to send it to Amazon or send it to your local data center. So you don't have to have a whole lot of, you know, core router networking changes on your own side. And this shows once you have your uplinks in place, you basically have to define 2 VLANs within those uplinks. One is, as I mentioned, for your local data center. The traffic can be routed there through the local gateway. And then the other one, which is very important, is the second VLAN, which is called the service link. And the service link is the link that actually goes back into the AWS cloud. So if you remembered earlier, I talked about they can push patches, they can do firmware updates and all that type of thing. That's done through the service link. Also, when you're in the console, deploying instances to you know, your local availability zone to your data center, it's done through that service link. And the actual service link itself could either be a direct connect, which is this box. That would be a direct connect in Amazon. What we do is actually we use the public internet using VPCs. And so you can do that too. So basically, The idea is that set up your VPC, you set up the local gateway, and you're in action with Amazon. The thing to note here is within the cloud itself, there is this concept of outpost proxies. So there's a proxy running in the cloud that Amazon uses to handle all communications back to your local data center. In one of the presentations I was in, we talked about the fact that that link went down. What happened? So it's not good. You want the link to stay up, but you're not out of business. If the link were going to go away, you still have your local instances running, providing services to your local facility. But what you have lost at that point is all manageability of those instances. So if you needed to add, disk space to it, create snapshots, technically you could turn them off by RDPing into them on your local network, but you lost all connectivity to them. So you really don't want to be in that state very long. They indicated you could probably go about 8 hours and still be in pretty good shape. But once that link is gone, they lost all monitoring capability of your hardware too. So Nitro, I wanted to talk about Nitro because that's core to this environment. I talked to you earlier about James Hamilton, this presentation he gave back in 2016, and when I was listening to him, he was talking about routers. Amazon used to have Cisco routers in their environment, lots of Cisco routers in their environment. And so the issue that they ran into is whenever they needed to have new functionality or fix problems, it just took a long time to have that happen working with Cisco. Because Cisco built their routers for hundreds of thousands of customers and built the code base for functionality that in Amazon's case, they didn't need. So they went through a process of designing their own chipsets. So they have engineers that design the silicon type chipsets in their own routers, and they standardized on a non-standard, I don't know if it's in this, but it was 25 gigabytes, which was not a standard back in 2016. It was more 10 and 40. But that was the most efficient for how they wanted to run their data centers. Take a look at that presentation if you get a chance. It's very good. But the point is, that's when I first heard about Nitro. It was back in 2016 they were talking about it. It's a program that they had in place about how they were building specialized hardware for their facilities and, in this case, for servers. So originally, the server consisted of the hypervisor, the networking, the storage, management, and security and stuff, all built within the actual hardware. Just for the most part, what we're doing with VMware today with our servers. The first phase of Nitro took the networking card off of the server, and they built their specialized chipset with networking capabilities in it to work with their facilities. And so that offloaded CPU, the requirement of CPUs on the actual host, so it gave CPUs back to the instances running on it. And it also made it more secure. Then the next phase was to take the storage off of the host and build a specialized card for that. So then they build a Nitro card for storage using SSD type storage. And so for instance, if you're doing encryption and stuff like that, and basic stuff, all that offloading processing now happens on a specialized card, and it gives back CPU power to the instances. And then finally, in 2017 timeframe, they took the management portion off and put it on a specialized card, and also built a special Nitro security chip card to make it more secure. And the other thing they did is prior to that, they were running, I believe it was Zen hypervisors for the underlying core of their host out there. And they designed their own hypervisor, based off of Linux that then ran on a specialized card. So at that point, all the CPU power went back to the instances. And if you can remember when we went through the process of moving from the 4 series to the 5 series, we had to deal with driver issues and stuff like that. That's why, because all the underlying hardware at that point changed. And the other thing that drove us to it was the fact that we had a 30% efficiency So in other words, we have 30% more performance for the same cost or less. And the reason how we got that 30% is basically they put these nitro cards in place and gave all the CPU power back to the instances. So this is just basically what I just said, but the thing I wanted to point out was the actual nitro security chip. So that is in the Outpost. So this is another probably about 10 minutes worth of presentation talking about the networking configuration that I went over real briefly, and also going to talk about the nitro hardware. So if you have a chance, take a look at it. So this nitro security key is key to Outpost because basically it's the encryption that occurs for the stuff that's on premise. The only way that Amazon's going to recognize this hardware in your facility is based on that nitro chip and nitro card to validate that it belongs in your primary network in AWS. And the other thing that's kind of unique about it is the fact that the last bullet item there, to destroy data, they use that nitro security key. When we deal with hardware on premise and we pull it out of our data center, we typically have to pull out the hard drives and shred them and get them destroyed because we have sensitive information on that. You don't know where it's going. The way that Amazon approached this with Outpost is there's this physical device that plugs in the front of the actual 1U server. So if you were ever to take the server out of the rack, you could not do that without this little module coming off. And actually what's in this module is a specially built chipset that does the security portion of Nitro. And so what happens when you want to destroy your data is you pull this off. If you notice in this diagram, there's a little screwdriver and a screw. So the idea is you take a screwdriver, turn the screw, and it crushes and destroys the little Nitro chipset that does all your encryption. So at that point, everything associated with that physical server is now essentially been shredded because it's worthless without that chip. So I thought that was pretty unique in the way they did things.
Is that they can reuse the rest of the device?
Yeah, I would assume basically they have a different encryption keys, different chip, plug it in there, and then deploy it again.
How fast do you think you could do that with federal agents coming in the front door?
Well, yeah, the policy,
Robots. Asking for a friend. Yeah.
Okay, so a little bit about pricing. So to get your foot in the door with Outpost, you have to commit to 3 years. First thing is you purchase a device and either pay all up front or partial up front, just like we do today with reserved instances. You have multiple options there. The other thing to note is that the BDP discount comes into play too, so that would get applied just like we do for everything else we're running in AWS. This is just an example of a screen you go to do a configuration of what would be shipped based on if you wanted the instance types to be in the M, C, R, I class type of thing. There's multiple options there. But the thing to note here is smallest configuration is 4 M5 12x large. That's the smallest you can get with 2.7 terabytes. So what that breaks down into, and when you think of 4 M5 12x larges, you don't have to just run 4. You can split those up into 48 M5X larges. So with that configuration, the smallest they have is 48. In our case, we run a lot of M5s in the cloud, and I think the highest we go is 10x for maybe some of the banner stuff. But for the most part, we're running just plain 1x M5 servers for the majority of the stuff that requires these kind of resources. But the point is, one virtual server would be 4 VPC CPUs and half the amount of memory of 16 gigabytes, and then it can burst up to 10 gigabytes for networking. And the cost for that is a little over $6,900 a month without any type of discounting occurring. That price does include the license for Linux, so you can run Linux on these instances. But if you want to run Windows, then you have to purchase a license from Microsoft to run Windows on. So at that point, it'd be similar to what we do in our data center today. With VMware, we purchase core licenses from Microsoft to run on top of VMware. And then, of course, you have to pay for, it's not showing here, but the actual power and cooling in the facility it goes into. Granted, we would be hard pressed to build a highly efficient server that supports that, like Amazon does. So it's not going to take up as much power and cooling and stuff we have, which they're got to pay for. And then the bottom one there is you need an enterprise support agreement, which means that you're locked into 3 years of enterprise support, and enterprise support is roughly $15,000 a month to have that. So this is really designed for those use cases I brought up in the beginning. You know, pretty large data centers have a real good use case. They're doing lots of processing, a lot of low latency type stuff. It makes sense. For us, we'd be hard pressed for the stuff we have on campus today to say we need 48 servers with 16 gig each, and just not a use case for us.
I'm thinking about doing some machine learning.
Yeah. I haven't said that the VMware side of it, if we were to think about doing something there with something, maybe it makes sense. And then the interesting part will be when they do support S3 storage. What does that look like? My assumption is you're still going to need to have the bare minimum number of servers in there. So,
John, is there a price premium for this, or is it literally the same cost you would pay for 48 and 5 extra layers?
there is a cost premium. And I did the math on it. And essentially where it came out to be kind of apples to apples is when you start talking about Windows. Because you pay a pretty good premium for Windows and AWS for licensing, whereas you figure from a higher education discount for Windows running on premise, then it starts to become apples and apples. But if you were to compare just a Linux instance compared to what you can do in the cloud, it's about 20% more at least.
Okay.
This is just an example of different configurations you can do, and obviously they get very, very large quickly. Just something I pulled off the slide. Everything I just talked about on one slide. So if you stay on the slide, you can print that out and put it on your desk and know everything about Outpost. So I have Jason here from AWS too. He's our TAM. So I know we're about 10 minutes over now, but if you do have questions and I can't answer them, Jason's here to help out with them too. So, thanks.
All right, thanks everybody for sticking around. Grab some more foods and drinks, and hopefully we'll see you again tomorrow.